This is Little Thirsty Vampires by Damasosos 92 with some new constraints which are vampire cell here. So for the rules we have we must place all the digits from 1 to 6 in every row, every column, and irregular regions, so there are some irregular regions here. Then digit in cage cannot repeat, so these cannot be the same, and must sum to the total in a small corner. But we have 3 pink cells here which are vampire cells, and they take 1 sip of blood from orthogonally exactly 1 sip of blood from an orthogonally adjacent cell, which means that this one takes 1 sip of blood from one of these. And for cage purpose, the vampire cell count is increased by 1, so this would be increased by 1. And the taken cells, the total count for decreased by 1. So if it were this way, for instance, this would be increased by 1. So this would be higher than 9, than 8. So 1 plus 8 would be 9, and this would be no, the other way. If it were this way, this would have been increased by 1 from this cage, taking 1 out of this cage to place it here. So this would be 9 and this would be 13. And that's for the rules. Here we have some cages of 12. Of course, it can't be. Well, we know that this is increased by 1, so this is indeed a 5, 6, and it could be 5 increased by 1, which would be 6, or 6, 6, or 6 increased by 1, so 5, 7, to get 12. So we don't know yet. And it takes either from here or here. But then this would sum to 4, which is 1, 3, and which clash with this one. So indeed it takes, I will draw a little line like this way. It takes this sip of blood from this cage. So this is 14 plus 1, which is taken to get it there, which is 15, and this is indeed 4, 5, 6. These are the same. This way, maybe. This is unaffected by this vampire, so this is natural 3, 1, 2, and here 3, 4. We have a cage of 4 cells summing to 10, so this is 1, 2, 3, 4, these are 5, 6. Now we may use law of leftover over these 2 rows. This is quite limited kind of set, but an easy one. It means that these two rows, so I will use it here because it's symmetrical here. So these two rows contain all the digits from 1 to 6. This region and this region contains all the digits from 1 to 6. These are common digits, so we can cancel them from both sets, and we have these two cells which are equals to these two. So I will use it color this way because this is the 5, 6 and must contain this one. Like this, so this is also 1, 2, 3, 4. And so we have the same here. So these two, which are protruding out of the row, are equal to these two. So this is the orange 5, 6, which could have been deduced here also. And these are the same. Let's color these. We have 4, 5, 6, so we have no 4 here. And so these are the same. So this is not a 4. This probably could have been deduced using some other meaning, but I find it useful. So there's a 4 here, which means there's a 4 here, because these are the same. This is 1, 2. So there's a 3 in these. This is the purple 5, 6. So we still have to place the purple 5, 6 for this, the orange 5, 6 goes there. Leaving one of these. So it doesn't go there, and for this color it goes here. here for this, because it's a kind of X-wing. Oh, there's no 4 here. 2, 5, or 6. Which is the purple one, not this one. The orange one. We have 4, 5, 6, which is the maximum, so this cell cannot take it from there, nor there. We'll put a little mark there. So where goes? This is 3, 4. And the gauge of 8, so this has been increased by some, well, it can't be this way in the same gauge because it would require another 4, so it goes down, and this is a 3 plus 1, taking from this gauge, and there's no 3 here. This is 3. Gauge of 10. Well, it's like this gauge. It was increased by 1, so this is 11 minus 3, and we still need for these two, we still need 8, well, which must be 2, 3, 2, 6, 2, 6, so indeed this is the purple one. And these are the 4, 5, 6, 3, then 1, 5. So this is a 6, and it's summed to 6, so it must be value taken from this SIP, so this way, and so this is a 1, 1 minus 1, 0, and 6. 5, 1, 2, 5, and 1, 2 to finish the puzzle. That's a fun constraint.